right. Okay, so now basically we're dividing the circle up into minor arcs, major arcs, and actually a semicircle. But everyone knows what a semicircle is. Now, what exactly is a central angle? A central angle is just an angle whose vertex is on the center of the circle. So for this question right now, you would say E is the center of the circle. Does everybody agree with that? So when I say CEF, that is called a central angle. And if I say FEG, that is a central angle. And HEG is also a central angle. All right. Now, the central angles, when you look at them, divide the segments of the circumference, which is called an arc. This arc is said to be a minor arc. All right. And it's a minor arc because it is less than 180 degrees. All right. A major arc is more than 180 degrees. And a semicircle obviously would just be 180 degrees. All right. Now, how do I get a major arc? You're now going to learn that angles can be greater than 180 degrees. All right. So that highlighted red is a major arc. The green is considered a minor arc. All right. There isn't a semicircle on here, but a semicircle would be 180 degrees. Now, you define a minor arc, it's real easy with two letters. So if I wanted to talk about the measure of CF, it would be CF, and then this is the symbol. All right, very simple. All right, that would be considered a minor arc because it's less than 180 degrees. Now, when you talk about a semicircle or you talk about a major arc, it's going to require 3 points. All right, because if I just said CF, CF is always referring to something less than 180. All right. So if I wanted to talk about the major arc, GHC, you would have to label it GHC. You couldn't just say GC because it would look like the minor. All right. Hopefully that makes sense. I think most people understand that. So you could say GHC, and that would be considered a major arc. All right. Now, I'm sure you all know how many degrees in a circle? 360. All right. Now, why is there 360? All right. Well, believe it or not, the Babylonians are the one who decided to say there are 360 degrees. And their logic was 360 is just divided by or divisible by so many numbers that, pass that down to James, that we're going to choose 360 degrees. All right, so it was just some random thing. If it were me, I would have just made it what? 100 degrees. All right. And then later on, they developed a new way of measuring angles. And you will learn this in pre-calculus. They talk about radians. All right. And that's how we actually should be measuring angles, with radians. All right. Not in degrees, because 360 degrees actually is just made up. All right. There's no reason for them to say there are 360 degrees in a circle. And like I say, the higher up you get in math, the more you will transition to measuring in radians rather than in degrees. All right. So again, we have minor arc, we have major arc, and we have a semicircle. All right. Now, when you talk about measure and you talk about length, I used to get these things mixed up. All right. When you measure an arc, you measure it in what units? In degrees, right? And length will be measured in what? Units. All right. So you have to be careful. I used to get those terms mixed up. All right. When you measure, you're measuring in what? Degrees. All right. And when you are talking about a length, that's when you know you're talking about units. All right. So be careful with the terms there. All right. Because on the test, I'm going to ask for the measure and I'm going to ask for the length. And sometimes kids accidentally put down the length when I ask for what? The measure. All right, so the measure of all of the arcs are going to now be between 0 and 360. But believe it or not, when you get into your pre-calculus class, you will be able to talk about degrees that are 700 or 600 or negative degrees. All right, and it's not that difficult, actually. All right, but right now, I want to talk to you about arc length. All right, so all the way around the circle is called what? Circumference. All right. So if I said your radius was 2, what would be the circumference? Yeah, 4 pi, right? All right, your circumference would be 4 pi. Now, if this is 90 degrees right here, then if I said the radius was 2, and what I'm trying to tell you is, you know, the formula intuitively. All right, if I said the radius is 2 and that's a right angle, then what is the length of that arc?
90 divided by 360 times.
No, just tell me the length. You should just intuitively know. That's obviously how long. Tell him.
1 half.
No. What is it?
Is it 2 round 2?
What is it? Of course, it's pi. All right. It's just pi. How do I know it's pi? If the circumference is 4 pi, divide by 4, right? Because 90 degrees is what? A fourth of the circle. All right. I never, and like I said, I hope you're listening to me, because this oftentimes comes up on the SAT and the ACT. And I personally never understood why there's any problem with this whatsoever. All right. Everyone in here, we talked about the circumference. We've been doing that literally since 5th grade. So everybody should know the circumference is pi times the diameter, or 2 pi r. Then when I ask, okay, what's the measure of an arc? And I ask you to recite the formula, people act like it's the most difficult thing in the world. Like, that's the formula for arc length. You don't have to write it down. That should just be simply obvious, because what is 2 pi r? It's the circumference, correct? 2 pi r is the circumference. Now, what does this mean? Yeah, x is the angle. It's the fractional part of the circumference. Right? Is everybody with me on that? All right. So if your central angle is 100 degrees, then your arc length will be 2 pi r times what? 100 out of 360, because you're only measuring 100 degrees out of what? Out of the 360. Now, again, I don't understand the confusion. All right. But every year people panic on their test and have trouble with all these formulas. All right. And I'm of the opinion you should just know that. That to me is obvious. Right. And I want that to be obvious for everyone else. All right. So one more time, I'm going to say it. 2 pi r is the what? Is the circumference. So your arc length is just a fractional part of the circumference that you're interested in looking at or interested in finding. All right. Does that make perfectly good sense? All right. It's super easy. All right. And again, we're going to go through and do a few things now. And I feel like I could almost skip this entire chapter, because it's just formulas. And all you have to do is know the formulas and you just plug the numbers in. That's why second semester is much easier than first semester. All right. The problem is you got to keep track of all the formulas. All right. So with that being said, let's look at number 1. So obviously, the measure of this is going to be how many degrees? Is everybody okay with that? 80 degrees, because the angles of the circle add up to 360. All right. So now, again, not that it's such a big deal, and I'm sure you can do this, but Help me out with 2. 150 degrees. Easy as that. And now you're just supposed to let me know if you don't know something. All right, because it will get a little trickier maybe. All right, now it says that BD and AC are diameters. All right. Identify each as a major, minor, or semicircle. All right, so what is the measure of BA? It is a what? Yeah, it is minor. Now it's asking for the measure. This is what I was trying to tell you. The little m means measure. All right, so what's the measure? How much?
136.
For BA, this guy right here.
Oh, no.
For this guy, what is that? It's obviously 44 degrees. There's no difference between the angle measure and the arc measure. That's what they're trying to tell you, which should make sense because that arc is being swept out by the what? By the radii, right? If you move along, that's the arc. So everybody should be able to tell me BA is 44. And then of course, everybody should be able to tell me that BC is also a what? Minor arc, and its measure is what? Come on, guys. Yes. I can't believe you guys are using calculators to do that. Just do 180 minus 40 and then minus 4. All right, that's how you should be doing it. All right, so now let's look at CD. Obviously, CD is what? 44. All right, because it's a vertical angle. Now, here's where you have to be careful. All right, so they're asking about ACD. So you have to go from A to C and then to D. Hope. Oh, I'm sorry, ACB. I can't read. A, C, B. So that's everything but what? Everything but 44, right? So we can say 360 minus 40 is 320 minus 4, 316. And of course, we would put down there that's major. All right, now let's see if I can do the next one. Well, BCD is kind of obvious because they tell you that BD is a diameter. So BCD is what? 180 degrees, and we call it a semicircle. All right, and then let's do AD. AD is going to be what? How much? Minor, and it's what? 136 degrees. I told you, simple, simple, simple. All right, so here we go over here. All right, now notice it says use circle O, all right, to find the length. Now we're finding length. All right, now I tried to get rid of this, but I left it. Round, I don't like rounding. What do I like? Exact. All right, so that's one less thing you have to do. All right, so DE, find DE if the radius is 2 meters. All right, so automatically the circumference is what? 4 pi, right? Now I need to find the length. Notice it's not asking for the measure, right? That's what I'm trying to make sure you hear me. All right, measure and length are completely 2 different things. You measure an angle with what? Degrees, and you find the length using a unit, feet, inches, yards, miles, whatever. All right, so if the circumference is 4 pi, how much is DE?
1/3 of 4 pi.
Right, exactly. I want you to be able to say, well, the angle is how many degrees?
120.
So that's how much of a circle? 1/3. If you didn't know it was 1/3, you would just put 120 over 360 and reduce it. But everyone in here knows it's 1/3. So you should be able to tell me the length of that arc is what? 4 pi over 3 what? Meters. All right, now it's much easier to help now. Anybody have any questions with that? All right.
Why would it just be 120?
120 what?
No. No.
The length is a unit. If they said, what's the measure? You would tell me it's what? Tell me. Yeah, 120. You understand what I'm saying, right? So already that's why I'm saying I understand the confusion. It's not asking for the measure. If I ask for the measure of DE, you would tell me it's 120 degrees. But I'm not asking for that. I'm asking for the length. If you walk from D to E, how far are you walking? 4 pi over 3 meters. All right, now can anybody tell me approximately what 4 pi over 3 is? I've always been amazed that kids don't know that either. That's approximately what? If you had to guess, approximately what? 4. Everybody should just say 4, because pi is pretty close to what number? 3. So whenever you're asked to approximate, just make pi what? 3, and you're done with it. All right. So we could say it's about 4 meters. And if you want to look on your calculator, 4 pi divided by 3, all right, you will see it's pretty close to what?
4.
Yeah, it's pretty close to 4. All right. But I don't care about that. Exact answers are way more important. Exact answers are more important. All right. So now they're changing up the diameter. They're telling you that it's 7. So right off the bat, I'm going to tell you the circumference is what?
7.
So that's how I do it. I just write 7 pi, then I figure out what fraction of the circle are we interested in? D, E, A. I'm interested in 210, right? So if you want to, you can just put 210 over 360, and then that can reduce to 7 over 12. And so then everybody should be able to look at that quickly and say, well, then that's just what? Yeah, 49 pi over 12. And we're also practicing our fractions. All right, we're also practicing our fractions. Everybody good with that? All right, so let's look at the next one. So if BE is 24, BE is the what? Diameter. So we just say that the circumference would be 24 pi, and then I'm measuring BC. And BC is what? 45, which is, we all know, 1/8 of a circle, correct? Because it's half of 90, and there's 4 90s, so it'd be 1/8. So then we could just say this is what? Come on, help me. 3 pi, and I forgot the units, guys. Make sure you put the units down. 3 pi feet. This one's inches. Is everybody agreeing with me on that? That's not that hard, right? Everybody's good? All right, so now let's check out DO. What is DO? Help me out. Radius, so the circumference is 6 what? 6 pi. And then let's measure CBA. So that's what? 135 out of 360. And we all can see that that simplifies to what? What is it? 3 over 8, because you're just dividing by 45. So from there, your final answer would end up being, help me. Yeah, come on, guys. Everybody can do that, right? I prefer that you not use a calculator. All right, everybody can, I'm just saying 6/8 reduces to 3/4. 3/4 times 3 is 9/4. Right, you got to be, good with numbers. Now, does anybody have any doubts about that? Anybody have any doubts? All right, now I see what I remember I was doing. You can round this to the nearest hundredth. Now, the reason I left that there, I remember now, was because I wanted you to use a calculator, but I don't care about that. Everybody knows to plug pi in on the calculator, right? Anybody have any doubts about that? We'd rather leave it exact. It's one less step. All right. Now, again, this is finding the exact length. All right, so this is the one where we're supposed to leave it in terms of pi, but I'm okay with that. So everything's in terms of pi as much as we can. All right, so hopefully you understand the way I'm trying to show you. MT is what? So the circumference would be 7 pi, and then RT is 50 out of 360, right? So I'm just going to write 5 over what? 36. That was pretty easy, right? And now I'm just telling you the final answer is 35 pi over 36 what? Yards. I don't think that's hard. Anybody have any issues? Easy, right? It's simple. Simple. All right, so let's practice 13. So now look at PR. PR is what? Radius. So I need the circumference to be 26 pi and MR. How much is MR, guys? One what? 130. So now instead of putting 130 over 360, just put what? 13 over 36. And now what's nice, these can reduce. 13, 18. So now we have 169 pi over 18 feet. Everybody's good with that? All right, what's MP? So the circumference, 4 pi. And then MST. Yeah, so it's just what? What was the answer? Yeah. Say it again. Which is? Yeah, just say the answer. Come on. I want you to do the math in your head. 2 pi what? 2 pi inches. Okay, PS, what is PS? So the circumference, 20 pi, and we need what? Which is 230 out of 360, right? So that's just what? 23 over 36. Then I can reduce by a factor of, and then I think it's 9, right?
Oh, yeah.
All right, 115 pi over 9. I just don't think that's that hard. Everybody's agreeing? All right, so then what I did was here, what does M stand for again? So our answer is going to be in what? Degrees, right? So all these things with the M, just degrees. And then more arc length. All right, so that's the easy stuff. All right, so then I found some nice problems here for us. All right, so let's take a look at 32. All right, skip all that other stuff. That's the easy part for you to just go back and practice. All right, now let's talk about some of these that are tricky. Now, come on, please participate in this, guys. I'd rather help you and, you know, but if you don't want to participate, then I'll just make you do it on your own. All right. So it says, refer to the table which shows the number of hours students at this school say they spend on homework. All right. If you were to construct a circle graph, how many degrees would be allotted for each category? Now, this is always on the ERBs, right? So if you're going to serve less than 1 hour, about how many degrees would it be? What do I have to do?
Divide by 360.
Multiply what?
So 360.
Yeah, guys. 8% of something is just 8 parts out of what? 100. So all of this is just telling me that it's 0.08 times what? 360. It's been a long time since I've asked you percent problems. All right, that's why I like these questions. All right, you want 8% of 360. So if you had to make it, you would tell me it's how many degrees? 28.8 degrees. All right, so if you're going to make a circle graph, then 29% would be what? Come on now, don't just wait for my answer. How much? 104.4. All right, and then, well, that was an easy one. Why is 58 easy? Thank you, it's twice 29. So everybody should be able to look at that and say 208.8 degrees. And then how did I know that 2% was 7.2 degrees? Yeah, there you go, 1/4 of 8. And all those numbers were easy to divide by 4. All right. And 3%, how did I know that is 10.8 degrees? Because 2% is 7.2, so 1% would be 3.6. So 3% is 7.2 plus 3.6. All right. Little things like that help. Hopefully you're just listening. All right. You can get better at mental math. All right. It makes you much better at advanced math. All right. If you understand numbers better than just typing on the calculator every chance you get. All right. Does everybody agree that was kind of easy, right? Now that we reviewed percentages. All right. So if we describe the arcs, so all of them are what? Minor except, yes. All right. 1 major and 4 minors. All right. Don't do that. I don't care about that. Okay. Now I really thought 33 was a nice little problem. All right. So what I'm going to do is I'm going to pause the video for a second and I'm going to put like 2 minutes on the clock. And I was guessing, I would have guessed 16,000 also. So, all right, don't feel bad. All right, I would have guessed 16,000. All right, but here's the problem. How many, what's the circumference of the circle? But the problem is, I don't know what the relationship is between what? Between 15 pi and 60 inches. Does everybody see that? So first thing you got to tell me, what's 15 pi approximately? About how much? 45, we'll just say 45 inches, right? Okay, 47. So, oh yeah, I see what you're doing, just multiplying by 3. But because we need to be a little bit more exact, we're just going to take 15 multiplied by pi on your calculator, right? And then you're wrapping it around once. Right, so you're subtracting what? From, yes, from 60, that's correct. Very good. So you went 60 minus your answer, which is approximately what? Say it again. 12.876. All right, so that 12.876 represents what fractional part of the circumference? Does everybody agree with that? So let me explain. I'll do a better job. Look, if I start here and I wrap myself all the way around and stopped right there, that would be how much? No, that would be 15 pi, correct? Is that us? All right, then we would just go a little bit further and we went 12.876 inches further, correct? So that 12.876 is the length of the what? Arc. So it's 12.876 divided by what? 15 pi. All right, that's the fractional part of the circle. And then, of course, you just multiply that by what? 360. Now, when you divide by 15 pi, remember to make sure you put parentheses around the 15 pi, or just use that number that you got above. All right, now we'll finish talking about it tomorrow. I really appreciate it, guys. Yeah, the homework is to finish this up, guys. The homework is to finish it up. All right, very, very nice job today, guys.